Hey everybody, so today we're doing joints, and so here's your joke for the day. Did you know that the average human body contains enough bones to make an entire skeleton? Wow, pretty cool, huh? I know, bad joke, but whatever. All right, we're going to the next slide. Oh, we have a Robert Frost poem, Road Not Taken. I really enjoy this one. I had this on the slides, and I forgot about this. So read that poem sometime. It's very interesting. He hiked with a friend of his, and his friend of his apparently was very indecisive and never could decide which road to take, and always wanted to go back and take the other one that they didn't take. Also, that was one of the stories that's behind this poem. It's also used in graduations as the last lines, especially. I took the one less traveled by, and that's made all the difference. But as a very uplifting kind of saying. But if you listen to Robert Frost, you actually pull him up online and listen to him. There's a video of him reading this poem, and he sounds. It's actually very pensive and very. It's an old man looking back in his life and sort of wondering what would have been if he'd taken the other road. So there's several interpretations of this poem, and so enjoy it. Next slide. So we're doing joints and synovial joint movements. So a joint is where two bones meet. We've called it an articulation, where two bones articulate. The joint comes from Latin jungere, or Old French joindre, from Latin articulare, to divide. So classification of joints, there's a couple different ways of doing that. You can classify them in terms of structure or in terms of function. And you can also classify them by the shape of the articular surface of the joint. So the shape of the joint itself. So we're going to go over the basic structure of synovial joints. And synovial joints are most of the joints that you know in your body, like your knee, elbow, wrist, all the wrist bones, finger bones, all that stuff. Then we're going to classify synovial joints based on the four types of movement and by the shape of the articular surfaces. Then we're going to go over joint movements. There's angular movements, meaning what angle does it go in, and special movements. Then there's going to look at the knee joint. We're also going to look at some of the other joints, the hip, shoulder, and elbow joint, briefly, and just go over what those look like. Then we're also going to look at fractures at the very end, and also some other problems with joints, just to fill in some gaps that are not in the book, and I think it's really interesting stuff to go over. So, next slide. So, structural and functional classification of joints. What does structural and functional mean? Structure means like the structure of the house or office building you're in. So here's a wood frame house. This happens to be Stephen King's house in Bangor, Maine. So you have a wood frame with brick on the outside, or maybe that may be siding on the outside of that house. I can't tell in the picture now. And then you have like office building. Here's the First Tennessee Plaza downtown Knoxville, which is all steel and glass. And so that's the structure. The function of these is like, well, one on the left is Stephen King's house. That's where you live. So that's the function of it. And on the right is the Bank Plaza. That's where people work. So you have the structure versus function. Next slide. So structural categories, we have fusions, we have fibrous, cartilaginous, and synovial. So the different categories of joints in terms of structure. So in terms of fusion, you have metopic sutures. So the sutures that are in the skull, we talked about those. And the epiphyseal lines, remember the epiphysis at the end of the long bones. And so there's an epiphyseal line where there was hyaline cartilage, and then it ossified, and so it left a line there. So it's a fusion. So it does not move. The ones we're really going to look at today are fibrous, cartilaginous, and synovial joints. Fibrous joints have dense fibrous connective tissue holding them together. Strong collagen fibers hold the joints firmly together. There's no space between them. Examples of those are the skull joints, the tooth sockets, and also what's called the tibial fibular joint. Remember the tibia and the fibula in the lower leg, and where they meet at the bottom is that's the distal end down near the ankle, and that's a fibrous joint. Cartilaginous joints have hyaline cartilage or fibrocartilage that connect the bones. There's no cavity, no synovial cavity and we'll talk about what a synovial cavity is in a second. There's usually some degree of movement. You have like the intervertebral joints in your vertebral column, so that's the discs between the vertebrae. The pubic symphysis, where the two os coxa, the two pelvic bones come together on the anterior side. And then the joint between the manubrium and the body of the sternum, so the top bone in the sternum connecting to the body of the sternum. So that's called the manubrium and the body junction, or sternal angle, or manubrial sternal joint. Synovial, those are a special type of joint. It's a freely movable joint, small synovial cavity between the bones. So you have a lot more movement than these other two joints for fibrous or cartilaginous joints. The synovial fluid is inside this cavity. It's clear. It's viscous, somewhat more. It's more viscous than if you have egg whites. Seen egg whites, it's more viscous than that. And then there's dense fibrous connective tissue on the outside of the joint, holding the joint together, and that makes what's called a articular capsule. It's a fibrous connective tissue all around the outside of the joint that makes a capsule around the joint and helps hold it all together. And joints are held together not only by cartilage and ligaments holding the bones together, but they're also held together by the muscles that are around them, muscles and tendons that are around the joint. So there's two types of structure that come into play into joints. You have both the basic ligaments that hold the bones together, and you also have muscles that cross over the joints. And those, by strengthening those muscles, you can actually strengthen your joints. Next slide. Then we have functional categories of joints. So we go synarthroses, amphiarthroses, and diarthroses. Synarthroses are immovable. So like the skull bone sutures, those don't move. Your teeth sockets, those are called, each one is called a gomphosis, or plural gomphoses. Amphiarthroses are slightly movable intervertebral joints. So they're all slightly movable. Tibiofibular joint, the sternal angle, the manubrial sternal joint, that's actually slightly movable, as well as the pubic symphysis is actually slightly movable. The diarthroses are all freely movable. So that's the knee, shoulder, fingers, toes, all those kind of bones. Your TMJ joint, all those kind of things are all diarthroses. And all diarthroses are synovial joints, and all synovial joints are diarthroses. So all diarthroses have a synovial cavity, synovial fluid, and an articular capsule around them. And all synovial joints that have all those, the articular capsule, synovial cavity, and synovial fluid are all diarthroses. They're all freely movable. It's 90% of the joints that are in your body. So next slide. So most fibrous joints, the T-socket, skull sutures, are immovable joints, which is a synarthrosis. Except for one example of fibrous distal tibiofibular joint, which is slightly movable. Most cartilaginous joints are slightly movable. So we go from immovable fibrous to slightly movable cartilaginous, like the intervertebral discs and pubic symphysis, except for the cartilaginous epiphyseal plates of long bones, and those are immovable joints. Synovial joints are all diarthroses, all freely movable, none are immovable. So you have fibrous, usually immovable synarthroses, cartilaginous are usually slightly movable amphiarthroses, and synovial are all movable diarthroses. Next slide. Here's a table showing the structural classification of fibrous, cartilaginous, and synovial joints across the top. So you have fibrous, cartilaginous, and synovial joint across the top. And so the type of tissue that you find in those, you have dense fibrous connective tissue. You have in the cartilaginous joint, you have hyaline cartilage or fibrocartilage. And a synovial joint, you have dense fibrous connective tissue outside and loose connective tissue inside. So, and loose connective tissue inside is making that synovial fluid. So you have areolar connective tissue on the inside of a synovial joint. Those are actually called synoviocytes that make the synoviocytes inside the joint actually make the synovial fluid. So examples of these joints, you have fibrous joint, tightly connected bones like the skull, sutures, teeth sockets. Cartilaginous joints, they're intervertebral spaces, so the discs between the vertebrae. Pubic symphysis, epiphyseal plate in growing kids are cartilaginous joints, and those epiphyseal plates are also called growth plates in kids. And sometimes if they have a traumatic accident, sometimes you can have damage to the growth plate, is what's a lot of times called commonly, but it's actually anatomy you're going to call it damage to the epiphyseal plate, the hyaline cartilage that eventually ossifies and turns into bone in adults. In a synovial joint, you have shoulder, elbow, knee, most joints in the body. Is there space between the bones? There's no. For fibrous joint, no space in the cartilaginous joint, and yes for synovial joint. Okay, so there's our structural classifications. Next slide. Functional classifications. You have synarthroses, amphiarthroses, and diarthroses. So synarthroses are immovable, and amphiarthroses are slightly movable. Diarthroses are freely movable. So examples of synarthroses: the sutures, teeth sockets, they're structurally fibrous joints, and functionally they are synarthroses. So that's that. Amphiarthroses, you have intervertebral junctions, pubic symphysis, and diarthroses, joints between the fingers, toes, elbows, knees, those kind of places. So comparison of functional and structural classification, most fibrous joints are synarthroses, fibrous and synarthroses. Most cartilaginous joints are amphiarthroses, and all synovial joints are freely movable diarthroses. So there's a couple examples of synarthroses and fibrous joints that are not synarthroses, and synarthroses that are not fibrous joints. And there's a couple examples of cartilaginous joints that are not amphiarthroses, and a couple that are amphiarthroses that are not cartilaginous. But for the most case, most fibrous joints are synarthroses, and most cartilaginous joints are amphiarthroses. So in this case, and for diarthroses, all of them are synovial. So synovial and diarthrosis almost become synonyms. All synovial are diarthroses, and vice versa, all vice versa. It's hard to write on the corner down there, sorry. And that's supposed to be a D right there. Okay, so, all right, next slide. And just for fun, just to make things a little more complicated, there's in terms of the structural classifications of joints, you have fibrous joint, a cartilaginous joint, a synovial joint. There are sub-classifications underneath structural classifications. So under fibrous joint, you can have sutures, gomphoses or gomphosis, or singular, and a syndesmoses or syndesmosis. So the skull sutures are one type of the sutures, and those are synarthroses, so they are immovable. Gomphosis, or the tooth, that's the joint between the actual tooth and the alveolus, the socket that's in the maxilla and mandible. Those are synarthroses, and those are also immovable. And the syndesmosis, means fastening or binding is what the word comes from. And they're often slightly movable amphiarthroses. So fibrous joints, we mentioned before, could be synarthroses or amphiarthroses. They're almost always synarthroses, but occasionally you have an amphiarthrosis. So the two examples of syndesmoses are the interosseous membrane between the radius and ulna, the tibia and fibula, and then the distal tibiofibular joint joining the tibia, fibula, and talus. So those are the three subclassifications of fibrous joints: sutures, gomphoses, and syndesmoses. Then under cartilaginous joints, there's two types of those you can have. Cartilaginous joints have hyaline cartilage or fibrocartilage, and you have a synchondrosis. And one example of that is the first sternocostal joint, which is an immovable synarthrosis, has hyaline cartilage. And the second example is a symphysis, like the intervertebral discs, the manubrial sternal joint. pubic symphysis. Those are all slightly movable amphiarthroses. So cartilaginous joints can be immovable synarthroses or movable amphiarthroses. If it's a movable amphiarthrosis, it's a symphysis. If it's a synarthrosis, then it's a synchondrosis. Synovial joints, those are basically those are subclassified based on the shape of the bones at the joint. The shape of the bones that make the joint. Shape of the bones at the joint, I guess is really what it is. So you have a planar joint, synovial joint, and a planar synovial joint, you have two bones that are flat and they slide back and forth. It's a two flat surfaces sliding back and forth across each other. Hinge joint would be like the olecranon and the going into the humerus. So if you watch your arm go up and down, that's a hinge. So raise your forearm up towards your shoulder and then back down. And then pivot joint, a good example of that is the when you say no, you shake your head back and forth. That's a pivot joint. Is the second cervical vertebrae with the dens, that odontoid process sticking up inside of the cervical vertebrae 1, and it allows your head to swivel back and forth. And you say yes, say no. Condyloid joints, those have a sort of a curvature to them, and they slide back and forth across each other. And then saddle joints is a type of condyloid joint, and then it's a little bit deeper condyloid joint. And then ball and socket would be like your femur fitting into the acetabulum in the pelvic bone, the os coxa. And then another one is your shoulder joint. So those are different types of subclassifications of structural joints. Next slide. So fibrous joints. Here's some pictures so we can finally get a look at what these things look like. And hopefully you followed along in your book as looking at these pictures too. So on the left we have a suture. In the middle we have a gomphosis, that's B, and then a syndesmosis is C. So here's the examples of them. So the sagittal coronal suture, up here going across the skull between the frontal bone and parietal bones, the coronal suture is a suture, and that is a fibrous joint. It's a syndesmosis also. Oh, sorry, synarthrosis. Sorry, it's not syndesmosis. It's a synarthrosis. Sorry. So that's a suture, and it's a synarthrosis. Then we have a gomphosis. So here's your tooth sticking down inside of the alveolus, the little hole, each of the holes that the teeth fit into in the mandible and the maxilla. In this case, it's the maxilla, since that's an upper tooth. Then we have the syndesmosis, C. So you have your ulna and your radius, and you have the interosseous membrane between those two. And that just helps hold those bones together, keeps them from flying apart. Because otherwise, all you would have would be just attachments here at the elbow end and at the wrist end, and the twisting motion that you put on your arm would cause those bones to come apart too easily at the wrist and the elbow. And so the interosseous membrane helps keep those bones together, so it doesn't put nearly as much stress on the elbow and wrist. And here's what it looks like. Here's your dense regular connective tissue here between the radius and ulna, and that dense regular connective tissue. You've seen pictures of that, and we're going to look at those again real quick. So next slide. Here's dense regular connective tissue. This is out of your guys' book, and you notice the straight fibers. So it's dense regular tissue. It also makes up tendons that are in the fingers, like it shows there on the left side of that little diagram there of the hand. You have parallel bundles of collagen fibers. So that's where you have fibroblasts that make that collagen. So fibroblasts, making fibers. So that's why they're fibroblasts, and blasts meaning cell. And then you obviously have your brown substance between a little bit of liquid in there too. So a little gel in there. Next slide. So that last slide was what makes up the interosseous membrane. So fibrous joints, you have the sutures, syndesmosis, and gomphosis. It's just another picture of the same thing. I'll go on and do the, you can take a look at that later if you want. Next slide. And so here's a tooth in the alveolus, showing the gomphosis, also referred to as the dentoalveolar joint. So it's fibrous. So you have these fibers here. So these fibers are called the periodontal ligament. Connects the tooth here. So here's bone. I'll outline that, making the alveolus there. And then you have these fibers. You can see all those little fibers that are drawn in there. And those constitute the periodontal ligament that connects the tooth, which connects to the tooth, and that goes actually into the tooth. And these are called Sharpey's fibers. And I think I may have a little picture of that on the next slide. So, and then you have, so here's the tooth, and there's the inside of the tooth with arteries and veins, so feeding the bone tissue in there, the dental tissue. Next slide. Well, one sec. So the dentoalveolar joint, or the gomphosis, is both fibrous and it's a synarthrosis, so it's immovable. The teeth don't really move in those sockets. Next slide. Here's cartilaginous joints, pictures of those. Hyaline cartilage as a synchondrosis, or fibrocartilage makes a symphysis. So A, here's your synchondrosis epiphyseal plate. So there's your growth plate right there. And then we have on the epiphysis of the long bone. And so in the middle, it gives you a axial skeleton plus upper part of the arm, showing where some of these parts are coming from. Then we have, let's go to B, so a synchondrosis. Places you find that would be the costochondral joint, the first sternocostal joint. So these joints right here, and here, and here, and here, and here, those are all the costochondral joints, meaning the joint between the ribs and the costal cartilage. And then the first sternocostal joint there is also a synchondrosis. So that's a type of cartilaginous joint. Then you have two types of symphyses, or two examples, I should say, of symphyses. Here's one symphysis, the intervertebral joint, so the discs in the between the, so the joint is the two bones with the disc. And then the other symphysis is the pubic symphysis right here. So between the pelvic bones coming together. Next slide. Here's a picture of hyaline cartilage from the trachea, just to remind you what hyaline cartilage looks like. It's very smooth, glassy, no fibers visible. So that's hyaline cartilage from the trachea. Hyaline cartilage is found in many of the cartilaginous joints. Next slide. Here's another picture that I took of hyaline cartilage on one of the slides that we have here in lab. Next slide. So here's the hyaline cartilage part there. Next slide. Fibrocartilage, this picture out of your guys' book, or one of the books showing fibrocartilage. This would be from an intervertebral disc, just reminding what that looks like. So it has these tough fibers that are compressible, so it helps maintain the space between your vertebrae, so that your vertebrae bones don't touch each other. Next slide. And here's a fibrocartilage, another picture. This was actually out of your guys' book. So you see the fibers there, and they're not all regular. They're somewhat irregular, but they have some sort of regularity to them. And so you can see how and the chondrocytes that are making those fibers, so that those tough fibers provide compression, resistance to compression. Next slide.